Okay, we're going to go over some of the features of YAAC, or yet another APRS client. First off, this is what the main window looks like. You have your map on the background. You have your roads, your rivers, stuff like that. This is Southern Arizona, so this is actually my home right here. I am KC7GNM. So we're going to go ahead and look at some of the features of this program real quick, and we're going to go through it one by one here. So if you come up here and click on File, you have you can load your APRS packets, objects and items, tactical names, drawing, GPS log. You can save all this stuff. You can print out. You can download OpenStreetMap, extract data set. We've already done that because it's as you can see, the data set's already there. You can download topographic files. I've tried to several times on this one because this is a beta. It doesn't work. It keeps crashing on me, so we're not going to do that. And then you got your configure. Now the wizard is if you just want simple stuff configured, but if you go to expert mode, you get a whole bunch of different tabs here. In the general tab, maximum age of view is how long you want to see an object on the screen before it disappears. And then the time to keep is 2 hours. So you can change that to whatever you want by clicking the little menu down and pulling down the menu. You can record your APRS packets to a log file, and you record GPS sentences to log file. We don't have a GPS hooked up to this, so therefore this is not going to work. Then you have your directory. It's just basically going to my users, Greg Thompson, YAAC log directory. So there you go. Format for AX25 log files, comma separated values. You got several different options here: Java serialized objects, comma separated values, or binary AX25 messages. Base directory for OpenStreetMap tile files is this directory right here, which is in the same subdirectory as the other one, but it's just in a different directory there. Message groups. This is all the groups you want to see on here. I have them all checked. So you have NWS warning, which is National Weather Service, all National Weather Service 8 advisories, the CQ from other people, National Weather Service watches, warns for all different kind of stuff, and QSY. So you can put all that stuff in there. You can add your own message group if you want, or delete a message group. So there you go. Go to the transmit tab. This is where you're going to set up where you're going to transmit to. So we're using APRS. So you have APJYC1. I have to look that up, so bear with me. APRS and beacon. So if you were just going to beacon out all the time, you'd want to set that. We're just using APRS, so we're just going to keep that there. Initial repeat rate is 60 seconds. Retransmission decay ratio by 2. And this is all default settings. I haven't changed any of this stuff. Stable slow repeat rate is 1800 seconds. Maximum retransmits of text messages is 3. So once it reaches that, it won't transmit anymore. Allow RF to IS gating. This basically allows the radio side to actually go through the internet side. So basically, it takes, what it's doing is it takes my radio frequency packets and transmits them over the internet to other stations that are actually connected to the internet. It also allows the opposite way. So allow IS, which is internet, to RF gating within one hop. So if, let's say, for instance, somebody's actually can be seen by my RF side, and somebody sends a message to them, it will attempt to, once it sees that on the internet, it will attempt to actually transmit that message via RF to that person within one hop. Okay, so that's how that goes. Then you have a supplemental transmit iGate filter. You could put other filters in here. Not too sure what that does. I haven't really messed with that much. We're using smart beaconing, proportional speed and range. So in other words, if I was actually moving, which I'm not, it would actually speed up and slow down depending on how fast I was going. So the slower you go, the slower the transmission. So in other words, if you're going like 2 miles an hour, it's not going to transmit, but every so often, maybe every 10 minutes. If you're going fast, it's going to transmit a whole lot faster. So corner pegging, it basically tries to figure out what the corner is when you know it's making a turn, and that's basically what that stuff is. 10 degrees plus 240 speed. Enable QRU Server, I don't know what that is. I will have to look that up. And TCP port number for HTTP queries is 8008. All right, so let's go up to Digipeat tab. When you're using APRS, actually we should enable those too. You want to use wide 1-1 and wide 2-2. That's the standard default on most of it, so we're going to be using that. And we're going to basically, the Digipeat path is wide 1-1, wide 2-1, so we're going to use that. All right, ports. This is where you configure your ports up at. The first top port is your internet port. All right, so if you click on this and you click on edit, you get how you set it up. So you set it up by putting in NOAA North America, which is noam.aprs2.net, and this is a APRS IS. So this basically APRS IS means it's the internet port. The server port number, you get this. You can find this on the internet by doing a net search for APRS IS, and you can get all this information to fill this in. Then you put your call sign in here. My call sign again is KC7GNM, and there's a password. It's a passcode based on your call sign. And if you're a ham radio operator, you can actually go on the internet and find what your APRS password is. Then a filter, basically, you could filter out certain stuff that you don't want to see, or if you want just a certain range of areas. Because if you select the whole world, you're going to overwhelm the program, because you're just going to be getting a continuous feed of information all the time. This is a direct connect through the internet. Actually, we're going to enable transmitting on the this port. So I didn't know that I had that disabled, so we'll go ahead and save that. All right. The next port is a serial TNC. Now, I've had some issues with this on here because, for one, none of the Macs I have a serial port on it, so I have to use a keyspan serial port or USB to serial port adapter. So there's a lot of funky little problems with it. If you notice, it says port name is TTY key serial 1, so that's what that is. But we're going to go ahead and look at some of the stuff on here. So this is a serial TNC. It's a 25-pin serial port on the back, and you will see pictures of that as well of the TNC. The baud rate is 1200 baud. I know that's slow, but the data rate for the actual RF transmissions is 1200 baud, so you're not going to get any faster than that anyways, so it doesn't really matter. Again, the call sign, we have the transmit enabled, hardware flow, hardware RTS, CTS, and since this modem or this TNC actually does use RTS, we check that box off, and then the rest is all basically left undone. And again, we're going to be wide 1-1, wide 2-2, and the protocol is APRS. We're not going to use open track because we're not moving, and we're not going to use raw AX25. And the rest of this stuff we're going to leave alone. All right, so we're going to cancel that because I don't want to. If I hit save, it's going to crash sometimes, so we'll do that. All right, let's go to the next one. Beacon name. Since we're not using a beacon, we're not basically, and none of this is actually set up to be using a beacon. However, this is actually where it's going to send out my position. So this is my latitude, my longitude. So I put that in there. You can get that off of Google Maps or whatnot to get your latitude and longitude. Now it is in degrees and minutes, decimal minutes. So therefore you have to have it in decimal minutes. There is no seconds on here, so it's 34.2. My display symbol, you can there's a whole lot of little things you can select on here. I mean, just a whole bunch of different stuff on here. I do believe there actually is an Apple. Let's see if we can find it, because if I remember right, I think there was one for an Apple computer, and I can't remember. Let's see if we can find it real quick. But yeah, they used to have one on here that I remember. Let's see if we can find it real quick while we're looking here. But yeah, you see all the different, there it is right here, Mac APRS. So let's go ahead and use that. So we're going to use a little Apple symbol as our symbol for where I'm at. Then you can set up all this other stuff. I usually just leave this all default. You could show your DFS power, height, gain. That's basically based on your radio. The amount of power your radio puts out, the height of the antenna, and the gain of the antenna, and the direction of the antenna, if it's omnidirectional or directional. So you're going to put the direction, you know, east, west, or, you know, whatever degrees it is actually transmitting at. Initial repeat rate is every 60 seconds. Retransmit decay is 2. And stable slow rate is 1,800 seconds. So there you go. All right, status. This is where you can put whatever status messages you want on here. In fact, let's go ahead and enable station status messages. And I'm testing out APRS on a MacBook 2008. So there we go. Preferences. This is just other stuff on here, like what font you want now. It was loading fonts up earlier, but this is the only font that it seems to want to like. So we're just going to leave that as default. And then behavior, we're going to get a beep if an alert message received, flash on special station reports, you know, stuff like that. So I just left this all default. I didn't change any of this for this video. All right, so we're going to close that out, and we can come back up to File. Then we could close the window, or we could exit YAAC. So let's go over here, View Map, Raw Packets. Now, if we click on this, this is our raw packet. And this is the window with the raw packets coming in. So if you wait here for a few seconds, you'll probably see a new packet come in because there's constantly position reports coming in. If you look over here, let's move it over some. This is the timestamp. So it's 14 July 2019 for this last packet at 11:36 with 14 seconds. The source of this is the call sign is WJ5 India, or WJ5. There's one that just popped in, and destination is this right here. So he's basically trying to send it to KABAL via KE7JVX-3. So trying to send that there. Now, if you look here, you see the little asterisk. Now this little asterisk is basically showing where I'm receiving this actual transmission from, because the way APRS works, you can actually send it through multiple hops or stations. It's almost like the internet on radio. So the little asterisk basically means that Mule, I'm receiving that directly from Mule. So this Red Mountain source, I'm receiving it through this protocol, through Helio, through Mule. So if we look on the map here, let's zoom out a little bit. All right, so I am here in the middle here. This is mine right here. Mule Mountain is over here on the right hand side. That's probably, let's see, let's click on it real quick. So we're looking at it being, let's see how far away it is. It doesn't say. Hold on. We'll view it as a radio if it lets me do that. View station on radio. So we're looking at this. It's 108 degrees from my station at 31.4 kilometers. So that's where it's located at. So it's 31 kilometers away. That's where I'm actually receiving that transmission from. Now, it is up on top of the mountain here. So that's the reason why it's able to see that. Now, Red Mountain is the one that we looked at, that pack that we were looking at before, is way over here on this side of to the west of me. Now it is actually, let's see, view station on radio. It is 42 kilometers away from me at 261 degrees. Now, I'm not hearing it direct because there's a range of mountains in between myself, which is right here, and Red Mountain, which is over here. So therefore, I'm not able to receive them directly. There is no mountain range between me and Mule Mountain. There is the San Pedro River Valley, which is right here. So this is a big valley, so I have direct line of sight. In fact, if I look out my window, I could see the antennas up on the mountain where this is at. So that's the reason why I could see that. So basically, someone sent Red Mountain sent a packet, Mule picked it up and retransmitted it out, and I received it. So that's how I got that. And it also shows their positions as well. So that's the reason why they show their position on the map here. So let's go ahead and zoom back in so you can see. Now, you see some people are driving around. Now, like this guy, KD50MJ, is driving around. So is N7FMJ. His last report was 15 minutes ago. His last report was 11 minutes ago. So these two are vehicles. That's why you see the little truck icon. And if you look here, he's got like a little line sticking out. That was his last direction he was headed. So if we look at that, he was going 20 kilometers per hour. Like I said, it's 35 minutes ago. He's in service. He's using a FTM 400DR as his radio. And that was his heading, was 247. So that's the reason why you see that heading that way, because that's about a 247. All right, so let's go back to view. We can actually show our raw messages. I don't think there's any messages on here yet. See, there's no messages in here, so we're not seeing anything. You can show radio view, which basically is going to show whichever one is selected, which I think was the last. Yeah, it was the last packet that came in. So that's what it's showing up here. And that's his little icon. He's got like a little antenna up here. So that's what that's showing. All right, so we're going to look at local objects, show heard station. So if I click on that, it shows all the heard that I hear directly from here. So this is all the stuff I can hear at my station here. It's pretty cool, right? Let's see, view. Show health monitor. I don't know what that does. Show transmitted iGate stations. So there's nothing there to show. Show connections. It's probably not going to have any connections because nobody's connected directly to me. And then show weather. So if there's weather in the area, it's going to show it on the map here. Show raster maps. We're showing OSM maps, OpenStreetMaps. So we're not going to use that. Map layers, so I can change different map layers here, so we're not going to change anything here. Show authentication key and show a DX report. So it's just another window pops up, DX reports. So if you're a ham radio operator, you know what a DX report is. Basically, it's a report of some station that somebody can hear, and they put it out there so people can make contact with the long distance station, is what that is. All right, you can filter stuff. You can make a blacklist. You can edit range limit. So if I want to only see a certain limit, so right now, radius of coverage around fixed is 12,000 kilometers. Use current local station position fixed or GPS. All right, so I don't have this enabled, so I'm not going to worry about that. You can locate a station, object, or amenity. You can query a station, so you can actually ping a station, stuff like that. You can bookmark this view, raw packet sniffer, which we're not going to mess with, and of course the help. I haven't really tried to help much. I don't know if this works much, but there's your about. This is YAAC 1.0 beta 140. It was made in 8 June of 2019. By Andrew Pavlin, KA2DDO. So he is actually an American ham radio operator. I can look up his call sign and see exactly what license class he is. So anyways, let's go ahead and look at some of the stuff on here. So you click on this and it brings you up to your home view. Now it hasn't changed my icon yet because that's what it was the last time it transmitted. But let's say, for instance, I want to ping, let's see, let's ping this guy right here, AA7JC. He's a good friend of mine. So he's got two different call signs here. If you notice, you got AA7JC and AA7JC-B. It's an IRC DDB gateway. He's on 440 voice, 438 525. If you want to contact him via voice, okay. So we're going to go ahead and query this. Actually, no, can't do that one. We can query this one, I believe. Yes. So we want to query, and we're going to let's see if we can pick up his software version. I don't think it's going to work, but we'll do that. So now I'm transmitting. If you notice, I am the source now. I transmit it to AA7JC-B, and I said $VER, which basically is version, and I'm not getting a reply back. So therefore, he's not going to transmit that back. So I mean, there's a whole bunch of different things you could do around here. Let's try querying this guy, station software version, and we're not getting anything back from them. So sometimes some of these stations don't reply back. So there you go. But we can ping these guys, which is pretty cool. So it's just like pinging on the internet. So we're going to go ahead and ping, and there we go. So there's the message right there. I got it back from K7RDG-C, and that was a ping. That's actually over TCP/IP. So I didn't even actually go over RF. That came over TCP/IP. So let's zoom out some more here, and we're going to query Mule. So we're going to ping them. All right, and you notice the ping. So he didn't ping back. So apparently ping's not set up on there, so I can't really do anything there. Some of these stations run KPC3s, which are, I would want to say, dumb nodes. That all they do is they digipede everything that comes in and they send it back out again. So if you notice, when I did send out this, it actually sent this out again. See right here where it says Mule, it sent it back out again. So this is actually my original signal here, okay, but then Mule Mountain sent it out again as me. So that's how that works. Basically, it's just repeating whatever I send out. So that's how that works, okay. Let's try this guy here. Let's see if we can get a version on his station. Sometimes some of these home stations do that, so you can actually get but it's not. So if you notice here, it went out. This is my original transmission. This is over RF, radio frequency, and then it goes right here, APRS to Mule. So Mule is where it's sending it back out, or sending out again. So there you go. That's how that works. But this is working actually pretty good. So now we can zoom out even more, and as you zoom out, you can see there's more stuff up in this area. So we could look at this, and let's see if I can drag this down. So we're going to drag this down, and then we're going to zoom in on this area. So this is Tucson here. So we're going to look at Tucson real quick. So we're going to zoom in, but you have some people driving around. This is actually a weather station here, because you can see the weather sock, or the little, how the wind is going, which way the wind's going. So if you click on this one, then you're going to get all this weather stuff. So the the wind direction is 259 at 9.6 kilometers per hour, up to 16 gusts up to 16 kilometers per hour. The temperature is 98 degrees Fahrenheit. 0% or 0 inches of rain today, 0 inches of rain within the last hour, and humidity is 26%. So these weather stations are pretty cool little things you can get information from all over the place. So, but anytime you see these little stars, these are nodes. The little home are home stations. These are digipeaters over here, and the little truck symbol basically means that's a mobile. There's also a Jeep there. So they have different ones, different symbols for all that stuff. So that's how that works. But if I want to get back to home, I just press the little home button and it brings me right back to my view. So yeah, you can zoom in pretty far here to get to see what you want to see. Now, as you zoom in, and you notice it takes a little bit longer to draw. This is an older MacBook, so it takes a little bit longer. So that's about the maximum you could. Well, no, actually, I can zoom in further. It's just taking forever to draw. There you go. So that's basically where my house is. So yeah, I know people are probably saying that, oh, you're showing where you live at and everything. Well, it's amateur radio, so they pretty much know where I live at. All I got to do is look at my call sign and look it up online on the FCC database, and it has my address. So it's not like I'm trying to hide anything. But that is just a quick rundown of the APRS that I use on this Mac, and it runs fairly well. This is actually a Java program. So let's zoom back out again. I'm going to stop it, and I'm going to show you how to start it up again. There's two different ways to start up this program. The first way, okay, so we're going to go ahead and shut this down. So we're going to quit YAAC. You can start it using a terminal. Okay, so right now, this is everything that's been happening in the background. So you can see all the different stuff that's been happening. So the easiest way to start it is basically you type in Java -jar YAAC.jar, and you hit enter, and it spawns the process. So therefore, there it goes. Now, this is the problem I've been having with it. Every time I have my radio hooked up to it, it stops. So in order for me to do that, I have to disconnect the USB, and I have to restart it again. So we're going to go ahead and restart it, and it's going to come up and say error opening port, discard this port. So we're not going to discard this port, because that's basically going to say discard the radio port. So we're going to hit no. Then we're going to plug in the USB to it. Now, if you look up here, the RF is grayed out. So we're going to click on that, and we're going to hit enable port, and this comes up. Now, it has an error, but it still works. So I just hit OK, and then I hit cancel. So it should, yes, it's still enabled. So therefore, I should still be seeing packets on here. So we're going to go to view raw packets, and let's see if we see a packet come across. So there we go, right there. There we go, right there. That's one coming across RF. And the only reason why I know that's RF because the other one will say TCP/IP over it. So these are direct RF when you see the Mule, because that one's actually coming off of the digipeater that I showed you that was way over here that I have line of sight with. It's not on here now because once you stop it, it clears out all the nodes until they pop back in again. So until I receive another position report, I won't see any stations on here. Now there are some that's popping up here because those are coming through the internet, but there you go. But now I can zoom out pretty much the whole United States. So I just have the United States loaded in here. I don't have any, or North America. I don't have anything loaded up beyond North America. So that's all I'm seeing right now. So as you as you zoom in, you're going to see different stuff pop in, different details. Okay. So that's basically it in a nutshell. Next, we're going to go over the actual equipment. I will show you exactly what is running my packet radio station. Okay, this is a Cantronics Cam Plus. This is actually a VHF TNC, or terminal node controller. Ham radio operators use these to send digital signals over the radio. If you look on the front here, you'll see over here where it says XMIT, lock, connected, and station. That side is for the HF side. Then you come over here to the right side, it says transmit, receive, connection, status, and mail. That's basically if you're running this as a TNC. We're running it in KISS mode, so you're going to see a lot of these lights light up if I receive a station at the time. Right there's a receive, so it's actually receiving something from the RF side from the radio. You have two buttons here, AM, FM. We use FM, so it's staying on FM, and the on-off button, and a power light. The light you see right here, the green light, is if we're on an HF frequency. You're going to see the two different signals come in, and you'll see it, especially if it's a good signal, you'll see the far left and the far right flashing real fast as it's decoding the actual signal. Radio teletype uses that a lot, so does packet radio. So that is the Cam Plus. Now it is actually, now just transmit it there, that's why you see the transmit light. So if you move over, this is the actual radio I'm using. I'm actually using an Elenco. It's a VHF radio, and it's set to 144.390 megahertz. And you're going to see that little light up there that says transmit receive. Now if it's green, that means I'm receiving a signal. If it's red, it means it's actually transmitting a signal from the packet radio program. Now this thing is connected via this cable here to the back of the TNC, and the back of the TNC, I don't know if you can see that, has the key span, which is connected to the MacBook. So there you go. That's how I have this station set up. So hopefully you enjoy this video. Please like, subscribe, and hit that bell notification if you want to see more content once I get it put up on here. So thanks a lot for watching.
We'll be right back.